Dear students, in this video, you're going to see how to represent your digital signal. Digital signal is nothing but a data stream of ones and zeros. How do you represent this as a signal? You have always seen that one is represented by a 5-volt pulse and 0 is represented by no pulse. That is a generic way of representing a data stream. But that is not the only one way of representing your data. There are various ways you can represent your zeros and ones. That is what these data formats are. In this video, you can see several types of data formats, and you need to remember how these data formats are written or generated. So hope this video will make you understand the data formats, or it is also called as line coding.
What is this term called? Unipolar, non-return to zero. Okay. Just check unipolar. Unipolar means there will be one polarity. Zero is represented by zero level, and one is represented by one polarity. Either plus 5 volts or minus 5 volts. Okay. So remember this unipolar. Okay. And it is non-return to zero. I told you why it is called non-return to zero, because the pulse will return at zero only. Right? That means pulse will return at the TS. The pulse returns at TS. If the pulse returns to zero at TS by 2, it is called as return to zero. Okay. So we have seen now unipolar non-return to zero, unipolar return to zero. Okay, you understood these two. Next one is polar non-return to zero. It's very simple, very easy to remember. What you see the circle symmetry. Right? Right? Now, see, these are the data. Okay. Polar non-return to zero. Just see the name itself. Polar non-return to zero. That means it returns to zero at TS. Okay. Now polarity. Right? There is a polarity for zero, there is a polarity for one. So your zero is represented by, your one is represented by one voltage level. Zero is represented by another voltage level. I've understood this. Data zero represented by another voltage level. What is the example? Let one be represented by plus 5 volt, and zero represented by minus 5 volt. Okay. Let, as an example, let this be plus 5 volt and zero is represented by minus 5. It need not be always plus 5 minus 5. It can be a different polarity for both zeros and ones. This is called as polar non-return to zero. Now, can you draw polar return to zero for this? Right, this is polar non-return to zero level. Just remember, this is polar non-return to zero level. That means every levels are same, right? Every level 0 and 1, it's same. That is called as level. Polar non-return to zero level. Okay. Similarly, we have another way of representing this data. Ultimately, you just have to understand what are all these things. Right? It is just nothing but representing your zeros and ones. That's all. At the end of all these methods, you will understand why we have to do this. It is just nothing but representing your zeros and ones in different waveform, different formats. That's all. Right? First two we have already seen. Now the third one is another way of representing polar energy level. Polar non-differential level. Where we have your one represented by plus V, zero represented by minus V. So polar, the two polars. Okay. So this is one way of representing it. Okay. Similarly, we have exactly. See here, you can see here. See, when the bit is 0, it is minus 5 volt, right? Minus 5 volt. When the bit is 1, it is plus 5. Once again, when it is 0, when it is 0, it is minus, right? 0, 1 again minus. 1 plus, 0 minus, 1 plus, 0 minus, 0 minus, 1 plus. Always, when you represent your data in terms of polar NRZ level, it looks like this. Right? Because see, you have to remember this, because there are nearly 10 types of representation you are going to see. 10 types. Right? And these 10 types, you have to remember. There is a possibility that it is confused. Right? That's a way to remember. You have to remember in that particular method. Polar NRZ level. Okay, so have you understood now this? Hoping you understood this. Let us go to the next. So how do you represent this here? See, this is called polar. Once again, this is called as polar NRZ. Moment you get polar NRZ, always your representation goes by plus 3 and minus 3. Always. Right? But here, there is a small technique used. See, what is that? Right? To represent zeros and ones. Okay, sequence of zeros and ones. See here. A binary data 1 is represented by change in the voltage level from its previously held voltage level. And binary 0 is represented by no change in the voltage level from its previous value. Remember this. Okay? Binary 1 is represented by change in the voltage level from the previous one. Binary 0 means there is no change from the change in voltage from the previous level. Okay, it's very easy to understand. See here. Remember this. Binary 1 means there is a change in the level. What is the level it's changing? Minus 3 to plus 3. Plus 3 to minus 3. Right? Like polar NRZ level. There is no fix. There is no fixation for 0 to be represented as only minus 3. 1 to be represented as only plus 3. The polar NRZ level, there is a fix. There is a fixation. 0 means minus 3. 1 means plus 3. Right? Otherwise, it is like that. But here, it's not like that. It just goes on how the voltage level changes from the previous level. Right? Now, let us take an example. Concentrate here. Let us take an example. See, I have a 0. I have a 0. Okay. Okay, so what is 0 means? There is no change in the voltage level, right? Right. Assume that this is 0. Since there is no change in the voltage level from the previous one, can you tell me what would be the level before 0? 0, exactly 0. See, voltage level 0 here. It encounters with the 0. That means 0 means there is no change in the voltage level. That means, is there any change in the voltage level now? No. Have you understood this now? Okay, no change in the voltage levels. Okay, what is the next bit? Next bit is 1, right? 1 means there is a change in the voltage level from its previous value. Previously it is 0. Now it is going to change its voltage level to this. Okay, now next. 0. No change in the voltage level. See, also 0. No change in the voltage level. Now you see that next will be 1. There is a change in the voltage level. What should happen? This will go to 1. Next is 1. Once again 1. Change in the voltage level from the previous one. See, change in the voltage level from the previous one. Okay. Similarly, next will be once again 1. Once again, there's a change in the voltage level. Next is 0. There's a change. There is no change. 0, no change. 1, there is a change in the voltage level. 0, there is no change in the voltage level. See. This is called as polar NRZ park. Just remember this always.
So
Okay.
let's say it starts from 1, let's say 1 kilo.
Of course, suppose if it is like this. Okay.
Start from like minus 2 to plus 2 plus.
Yeah.
I don't know if it is-
You are right. It will be given to you. It will be given to you. You are starting. The bits previous to this will be 1 like this. Right? You have to assume. One way that you assume it. Okay. Another way that it will be given in the question that the level previous to this will be 0 or 1, something like that. Right. Suppose if I say the level previous to this is, for example, say 0, right? Then you start from here, right? Always it requires what is the level here, always. It will be given to you. Right? Suppose instead of this, if I say level before to this is going to be 1, can you tell me how does the waveform changes? Suppose if I say level before this is 0, in this case definitely it is 0 only, because 0 it doesn't change its level, right?
So it- but-
Even how can it be 1 in the bottom?
This is 0.
Ah.
What is the bottom?
See, 1 means, okay, you mean to say, suppose if there is, no, it is going to encounter 0 here, right? 0 is represented by lower level here, right? Before this, okay, because it is 0, it is continuing here. Suppose if it is 1, you are right. Suppose if it is 1 like this, it is changing. No, it should not change its level. It will be like this. Suppose level before this is 1, okay. What is encountered is 0 here. It will change. It won't change. It will continue like this. Okay, you are correct. Can be anything. Yes, you are right. You are right. Okay, let's go. But always see that you will give. Suppose if it is 1, see next bit is 0, right? Right, exactly. Suppose if we say this is 1 because of the one more previous bit here, right? Because of one more previous bit here, okay? And this will be 0, there's no change. Yes, this is also correct.
So we're supposed to assume that even if the previous one is
You
1,
can assume.
either it's plus 1 or minus 3. Because that is when we
No, which one are you talking about? Plus volt, minus volt. Definitely, it is having only 2 levels.
Yes, sir. And the question is, suppose even if we given the previous value, as in this case 1, but the plus 4 or minus 4, we just saw we take 1 as plus V. Our waveform will be like
Yeah, see, anyway, see, this assumption is enough, right? Do I need to assume anything else here? This, see, what is required is just a level here, right? You need not worry about. Suppose if this is the level, low level, okay? If it is given low level, if next will be the 1, it will go up. If next will be the 0, it will go down. What is required is what level is it exists before this. It doesn't matter whether it's 1 or 0. I've understood this now. That's what I told you. It doesn't matter what is this bit. Have you understood now? It doesn't matter what is this bit. What matters is the level. I've understood. It doesn't matter. What is the level is? It can be 0 or 1. Okay. Then you start your next level. I've understood this now. You're not bothered about what bit is going to be here, right? But you just have to know how it changes its value. This bit may be 1 or 0. This bit may be 1 or 0. Right? Okay. Accordingly, the other bits will change, other level will change. Have you understood now? Okay. Let's go for the next. Everybody understood. These are very important. This is called line codes. It's very important. Sit properly. Do something, my dear. Huh? Whole semester you have not done anything. Okay, what is this? I just want you to do this. What is this? And you just have to tell me what is the relationship between the previous one and this. Okay, just read this. I don't have to give much explanation for this. Why? Exactly. Just opposite of the previous one. What happens here? Zero changes. Zero changes, one doesn't change. Right? So it is given a name called as polar energy space. So what happens here? Whenever there is a 0, there is a change. Whenever there is a 1, there is no change. If you have understood polar energy M, polar energy S is a reverse opposite of this. Opposite of this. That's all. Opposite of this. Just remember like that. Understood this? Okay. Now I'll just go to the next. You can see this from this example. 0 means there is a change. Right? 0 means there is a change. Okay. Can you tell me what will be the previous one for this? What will be the previous one for this? 0 means there is a change. What will be the previous level for this? This one. This level is 0. There is a change. Right? In the previous level, in previous example, what will be the previous level? 0 only, because 0 means there is no change. Here 1, here 0, there is a change. 1, there is no change. See here, 1, there is no change in the level. 0, there is a change in the level. 0, there is a change in the level. And see, 1, there is no change in the level. 1, there is no change in the level. Again 1, there is no change in the level. And 0, there is a change in the level. 1, no change in the level. 0, there is change in the level. Hope you are understanding now. Ultimately, what we are doing here is you represent your ones and zeros in a proper waveform. This is called as data formats. This is the way your ones and zeros are represented. Fine. Okay. Next. Now you just take down serially what are the things we have done so far. Can you take down in your book? What are the data formats we have done so far? Unipolar, NRZ. Next. Unipolar RZ. Next. Polar NRZ is very easy. Right? It is fixed. Zeros and ones are fixed. Right? Your 0 is represented by minus volt, plus is represented by plus volt. That's all. Next, polar energy mark, where there is a change in the level whenever there is a 1. Polar energy space, where there is a change in the level whenever you get 0. There is no change in the level whenever you come across 1. Understood this? Okay. Now let us go to one more. Biphase. See here, this is very interesting. Biphase. Okay, biphase. It changes its phase. The two phase. Right. Your 0 is represented by one phase, and 1 is represented by another phase. Right. What circuits you know, right? Okay. Right. So now, what phase we are talking about here? Okay. Now, in one cycle of pulse, okay, a phase represent a 0 degree phase to represent binary data 1. Another have a 180 degree out of phase. Let us practically see that, how exactly it looks like. Okay, how exactly a biphase looks like. Okay, see here. See, it's very simple to understand. Biphase. Okay, see, a pulse can be, something can be represented like this, high to low, and we can have something represented by this also, right? Suppose if this is your pulse width, okay, this is your pulse width TB, okay. You see here there is a change in the phase, okay, at TB by 2. Okay, now you see going from low level and it takes its phase at the TB by 2 and it goes up. Okay, this is to represent bit 0. I can represent bit 0 like this, and my bit 1 can be represented like this. So in the entire series of zeros and ones, your every 0 is represented like this. Okay, it's a one phase, and every 1 is represented like this. Everyone is represented like this. Okay, it's fixed. It's fixed. That's why it's called as level, biphase level, one level. Okay, so biphase level, and this is also given a famous name called as Manchester level, right? Okay, so you all remember Manchester very well now. Season is going on, right? Okay, so remember that and remember this also, Manchester level. Okay, now I told you a Manchester level, your 0 is represented like this, 1 is represented like this. See, 0 means it starts from 0 level, negative level. Okay, 0. Okay, see, you remember that in polar NRZ level, in polar NRZ level, your, suppose if I take a level like this, your 0 is represented by minus V, right? And your 1 is represented by plus V, right? Okay, this is what your polar NRZ is. Now in biphase, this is your TB, this is your TB, this is your TB. This is bit 0, this is bit 1. So in biphase, within this TB, okay, there is a phase shift, one phase. This is one phase. Okay, see, it starts from minus V to plus V. Okay, this is representing 0 and this is representing 1. All of you understood this? This is different now. This is going from low to high. This is going from high to low.
Then why is it on 0 degree phase shift? You know, why is it the other one 0 degree phase shift at this point?
So both are at same phase shift, na? See, there is a shifting from here to here, right? And there is a shift from here to here. Don't worry about the degrees now. Just see that it is there is a phase shift from here to here. There's a phase shift here to here. Don't worry about degrees, because here the moment you talk about degree, you get confused, right? Just remember this, right? See, this is your 1, this is your 0. That's all. Understood this? Okay. Now similarly, like you had polar mark, polar NRZ mark, polar NRZ space. Here also there is a change in the level. Here also there is a change in the level. We'll see that. Okay. But have you understood this? Tell me now. This is called as biphase level. Biphase level. One thing you have to remember always, that your 0 is represented like this. This is your 0, always 0. This is your always 1. And this happens within interval T. Now see here. This is 0, right? This is the sequence. This is the example sequence. In this example sequence, see here, in this example sequence, 0. How do you represent 0? This is 0, right? Symbol for 0. Yes or no? This is symbol for 0 in biphase. Now, how do you represent 1? Like this, within this interval. But it takes exactly the phase shift at the TB by 2. It changes the phase, right? By TB by 2. At TB by 2. This is very important. Okay? You don't make it somewhere here. That's wrong. At the middle. Now, similarly, 0. How does 0? This is your 0, right? Now, once again 0. This is 0, right? This anyway, if anyway, we can draw like this. Now, 1 means this one. Again, 1 means this one. Again, 1 means this one. Right? 0 means this one. 1 means this one. Okay? Again, 0. Again, 0 means this one. It continues like that. Suppose if there is a 1 here, okay, this is your 1. It's fixed here. Right? So 0 means this one. This is your TB. This is TB by 2. 1 means this one. It's always fixed. It's always fixed. Have you understood now? Okay. Note it down in your book. This is the next technique which you have done. Okay. You will be solving this. Okay. By different sequences. Okay. Then you will clearly understand this. Okay. This is biphase level. Okay. Now differential Manchester. See what's happening here. See what's happening here. Transition for 0. What is this transition? No transition for 1. Okay. Transition for 0. No transition for. See, have you checked the previous one? It changes the level. In polar NRZ. Okay. Mark. What's happening? Level is changing, right? Whenever there is a 1, level is changing, right? Have understood? Okay. Similarly, and polar NRZ, S is reverse of NRZ. Okay. Now, in the same way, here, 0, there is a transition for 0. There is no transition for 1. See, how does it look like? See here. Now you have to tell me what is the previous one. Okay. 0 means there is a transition. What happens? Transition. See, if it is like this, okay, transition means, okay, it will be like this. You will have a transition. Okay. If no transition means, if we have like something like this, no transition means next also will be like this only. Have you understood this? Transition, no transition. Okay. I will give an example. To this example, you will come to know. See here. 0. Okay. 0 means there is a transition, right? 0 means there is a transition. See, transition means if previous one is like this, if the previous one is like this, if the previous one is like this, okay, transition means, suppose this is your TB, transition means this level should change. If it should have a transition like this, this is transition. This level will change from here to here. This is called transition. Right? Suppose if it doesn't change, right? Suppose if the level doesn't change, say here, you are having like this. If next level is like this, okay, see, there is no change in the transition, there's no transition from here to here. Okay, so if 1 occurs, it won't change its transition. Suppose if there's a 0 here, what will happen? It will change the transition, it will become like this. This is what differential Manchester level is. Have you understood now? Right? Okay, we will see an example. Okay, through example will come. Have you understood what is transition and no transition? Okay, this is what transition and no transition. Through this example, we will come to know what is transition. Okay, now, as per the differential Manchester level, a bit, a binary 0, there is a transition for binary 0. Okay, no transition for binary 1, no transition for binary 1. Okay, binary 1 does not have any transition. Okay, and I told you what is transition. Okay, now see here, 0. See, you will be given only this. You will be given only this. 0 means there is no transition. Okay, there's no transition. Okay, so where we start? From the beginning. From where we start? So forget about this waveform. It's not there now. From where you start? Unless you have what is there in the previous. Can you do it? That's why it is given in the examination, in the question, that what is the previous level. If it is not given in the exam, for example, if it is not given in the examination, right, you assume yourself, right? Now, 0 is encountered. Now, 0 is encountered. Okay. When 0 is encountered, from where it will start telling me? 0 means there is a transition. Yes or no? There is a transition. 0 means there is a transition. Okay. So how do you represent, whether from the top, whether from the bottom? You don't know what is the previous one, right? Unless you know previous one, it is not possible. That's why here previous one is assumed to be this level. This is what previous one. This is what previous one. This is the previous level. This is the previous bit. Okay. Previous bit says this is the previous bit. Now next bit is going to be 0. 0 means what? 0 means what? There's a transition. That means it should start from here. There's a transition. Say transition. Now, next bit is 1, right? There is no transition. Is there any transition here? No, see, no transition. It continues from here. Now, next bit is 0. There should be transition, right? See, it starts from the next level. See. Now, next bit is also 0. Does it have to continue from here? No. Next 0 means not, there's a transition. Okay. Now 1. Does it has to go here? No, it has to continue, right? From the same level. Next is 1. 1 means no transition, right? Continue. Once again, 1. No transition. 0. There is a transition. It should start from here. Now 1, no transition. 0, there is a transition like this. This is differential Manchester level. Differential Manchester level. Right? Where 0 means transition. 1 means there is no transition. Okay, just write the note in your book. Okay. Next. Can I have a reverse opposite of this? It's possible, right? 1 transition, 0, there is no transition. 1 transition, 0, there is no transition. Okay. So next will be biphase mark. This is called biphase mark. See here. Okay. I'm not covering the opposite one. I'm not covering that opposite one. But I have something called biphase mark here. Can you tell me what's happening here? It's a mixture. Once again. Right. This is called biphase mark. What is biphase mark? Can you just read this and try to understand? See, whenever 1 comes, there is a transition happening through the TB by 2. Right, transition is there, but transition is through TB by 2. Okay. Whenever 1 comes, there is a transition. You are having this transition in between TB by 2. Okay. Now, whenever there is a 0, okay, whenever there is a 0, there is the data 0, no second transition. No transition, no second transition. See what's happening here. It's very simple to understand. See here. Whenever 0 means, you will not have a pulse something like this. You will not have a pulse like this. That's called second transition. There's no second transition. Whenever 0 comes, okay, A binary data 0 is represented by no second transition. Transition is there, but no second transition. Okay. Now, can you tell me to get the 0 here? Okay. Can you tell me what will be the previous level? Is it only one possibility? One answer. That's why it will be given. Okay. Now, previously it will be like this, for example. Okay. This is also 0. This is also 0. Okay. 0 means there is a transition, but there is no second transition. Right. So, whenever, if the next pulse is 0, there is a transition. Okay. But there is no second transition. It won't become like this. Instead of this, it will become only this transition. Here also 0. This also 0. If it is like this, now, for example, if the previous bit can also be like this. Previous bit can also be like this. I can have a previous bit. See, there's a transition. Anyway, there's a transition here. Every bit change will have a transition. Okay. This bit can also be like this. Yes or no? Right? This bit can also be like this. There's a second transition. Where there will be second transition? Either 0 or 1. Where? 1, exactly. Then this bit is 1. This bit is 1. If the pulse before this is given like this, then this bit will be 1. Okay? Now, I will ask the same question once again repeatedly. Suppose if the previous bit is, for example, is like this. Suppose if I give it like this. Can you tell me what is this bit? It is 0. There is no second transition. Transition is there from bit to bit. There is no second transition. Have you understood this now? Okay. Now can you let us learn this? 0. Okay. Now assume that this is 0. There is a transition. This is also 0. And there is no second transition here. This. Now next bit is 1. There is a transition. It will start from the plus V, but there is a second transition here. Next bit is 0. There is a transition, but there is no second transition here. It is full. Now, next bit is also 0. There is a transition, but there is no second transition here. Now, next bit is 1. There is a transition, but there will be a second transition here. Next bit is 1. It starts from the next level, but there is a second transition. Next bit is also 1. It doesn't continue here. It will start from the transition. There is a second transition. Now, next bit is 0. Next bit is 0. That means there is a transition, but there is no second transition. Next bit is 1. Of course, there is a change in the level, but it is second transition. 0. Once again, there is a transition. This is called as biphase mark. Just take it down. Okay. Just take it down. Can you just tell me what is this? If you understood the previous one, now can you tell me what is this? First. You yourself have to tell me the answer now. Opposite of biphase mark. Always remember, biphase mark is opposite, space is opposite of biphase mark. Polar phase is opposite of polar mark. Understood this? Okay. Like that, you have to remember these things. Okay. Now, what happens here? Your 0 is represented by transition. Okay. Now, can you tell me what will be the previous level for this now? Either it can be 1. 1 means, suppose if I give like this, can you tell me what will be the previous bit now? 1. Of course. Fine. Okay. Okay, see, 0 means change in the transition. There is a second transition. 1 means no second transition, it continues. 0 once again, it changes its level, but there is a second transition. 0 once again, it changes its level. There is second transition. 1, there is no transition, second transition. Similarly, 1, there is no transition. 1, similarly, there is no transition. 0, of course, it changes its level, but there is no transition. So there is a second transition. Okay. Similarly, 1 here, there is a change in the level, but there is no second transition. This is biphase space. Then what is this biphase multi-level binary? See here, bipolar. It's called bipolar. Okay, bipolar multi-level binary. See here, we use all these 3 levels: plus V, minus V, and also V. You are seeing using only 0 and plus volt, right? Or 0 or minus volt. It's called unipolar, right? Right? Then you have polar, where we don't use 0 level. You use only plus V and minus V. Right? Now here you see, use more than 2 voltage levels: plus volt, 0 and minus volt. See how exactly it is used. See here. You will have this sequence of zeros and ones coming out of your PCM or delta modulation, right? You have this series of this coming out of this. Okay. Now, how do you represent it? Using this bipolar NRZ, so bipolar non-determinate zero. See, there will be alternating plus volt and minus volt used to represent 1. Okay. But 0 is always ground level. In this, 0 is always represented by ground level, but your 1 is represented by alternating plus volt and minus volt. See here, how exactly it works. See here. Now, 0 is always 0, okay? 0 is always 0, okay? It's 0 level. It's a ground level, always fixed, it's fixed, no change. But 1 is represented by sequence alternative plus V and minus V. See the example here. First one which occurs here before you have 0, okay? It is, say, plus V, okay? The first one, okay? Now 0 is represented by ground, another 0 represented by ground. Next one it encountered. I said alternative plus V and minus V. Suppose if it is plus V here, what is going to happen here? Minus V. Next one, the next one which you get will be minus V. Okay. Similarly, next one, alternative plus V and minus V. See, next one is plus V. Next one is minus V. Similarly, 0 is now ground. 1 is, see, because previously it is minus V, this will be plus V, and it goes on like this. Suppose you may ask, nobody asked me the question, do I have to go up here? How does it depend whether to go up or down? Depends on previous base, right? Suppose previously, okay, if it is like this, if it is like this, right? Previously if it is like this, can you tell me what will be this bit? 1 or 0? 1. If the previous bit is like this, whenever next one encountered, it is going high. It depends on that. Just reading the question always. Suppose if I say that previously you will have something like this. Can you tell me how does your waveform change now? Tell me. This bit is 1 or 0. This will be 1 only. Now, see the next bit. Next bit encountered is 1. It will go like this, right? Now, of course, your 0 represented by all zeros. Okay. Now, can you tell me what will happen here? It will go up here. It will go down here. It will go up here. This will be definitely 0. This will go down. This will be definitely 0. If there is 1 here, what will happen? It will go up. The red one which you see, if you assume the previously it is 1. This is very important. In the examination, it will be given accordingly. You just go for it. Okay. Note down in your book. It is bipolar. NR Z. Okay. Now tell me what is this? Bipolar return to 0. Bipolar return to 0. Here something is fixed. Something is fixed. Bipolar return to 0. See here how it works. See, this is the TB interval, right? This is the TB interval. Okay. TB interval means 1 bit interval. Okay. Now this is TB by 2. This is TB by 2. Right? Now see, this is 0 level. Okay. This is plus V. This is minus V. Suppose if your pulse is like this, starts from here and it goes to 0 before TB. In TB by 2, it goes to 0. That's why we call it as return to 0. It goes to 0 at TB by 2. See, this is TB by 2. This is TB. It goes to 0 at TB by 2. We call it as return to 0. Now, this is for, okay, bit 0. Right? This is for bit 0. Okay. Now, can you guess what will be for bit 1? This is for bit 1. That's all. This is for bit 1. This is for bit 1. See, this is TB. This is your bit 1. Okay. Now, this is TB. This is 0, plus volt, 0, minus volt, plus volt, 0, minus volt. This is your this is your bit 0 or 1. This is bit 0. This is bit 1. This is 0. Can you just draw accordingly? See here. Here something is fixed. Bit 0. See this one. Can you see here? Bit 1. See, it returned to 0. It returns to 0 before TB. That's why you call it as return to 0. Now see here. Bit 1. Bit 1 is this one. Bit 0. This one. Bit 0. Again this one. Bit 1 again this one. Bit 1 again this one. Bit 1 again this one. Bit 0 once again this one. Bit 1 is this. Bit 0 is this. Here something is fixed. It's fixed. Right? This is called as bipolar return to 0. Understood this? Okay. Take down in your book how many you have to get me the number now. How much we have studied now. Okay. How many are there now? How many? How many?
11.
So far 11 over, right? We need 2 more are there. Okay. Which one? Previous one. Yes. Next one is very simple. Right? You have to tell me the next one for which it is equivalent. Okay? There's here it is just written to 0. Right? You have a similar one which is not written to 0. Okay. Just see this. Just go through this. Just go through this. By the time I take attendance, you have to tell me you have seen something very similar, but it will be like this. Very similar. It will be like this. You already studied this.